All right. Okay. Everyone hear me all right? Okay. Folks, after our unit three test, I gave you some of those textbook questions, not because we needed them, because from what I see in here, it's just nothing but talent. So our next unit is called factoring quadratics. And on this day of factoring quadratics, we learned I suppose it's like one of the most important tools of factoring, or maybe the most important step of factoring. And it's called common factoring. And you might be able to see this really, really clearly. In fact, I'm going to try my best to make it as clear as possible. So, do you remember the distributive property? Absolutely. You know that we kind of take this number out front of the brackets and multiply it by the things in the bracket, right? We're going to go A times B and then A times C. And we get AB plus AC. We get something like that? Yeah. And I know you even know FOIL at this point, so that's great too. Now, we remember the distributive property, that's great. Now, do you remember exponent laws? And that's what those textbook questions were kind of about. I know it's been a long time since we've talked about exponent laws, especially since grade 9, because in grade 9, that second unit, powers and polynomials, we really, really, really crank out some tough questions. But just remember, when we multiply, and I mean multiply, right? Like when we multiply powers with the same base, right? We keep the base the same, and what do we do with the exponents? Do you remember? Like something like this? We just add the exponents. So for example, if you have like base A, you have A to the exponent m multiplied by A to the exponent n, you just have the same base, which is A, and then you add the exponents together. So I think a decent example would be like, you have x to the power of 4 multiplied by x to the power of 2. That really is equal to x to the power of 6. A lot of us didn't really write that x to the 4 plus 2. I mean, you could, but at this point, I think you can see what's going on here. We are multiplying these two terms, right? The x to the 4 and x to the 2. The dot means multiply. Yes? Do you remember that? And we add those exponents like that. Lovely. And conversely, when we divide powers with the same base, we're going to keep the base the same. And I think you already know where we're going with this. We're going to subtract the exponents. So if you have, for example, a to the m divided by a to the n, that's going to be equal to a to the m minus n. Now, a lot of the times the division, maybe in grade 9 it looked like that a little bit, but really what we went towards was something like this, like x to the power of 6 over x to the power of 3. See, that's my favorite one. The reason why that's my favorite one is because this will tell me whether or not you truly know what's going on here. Does anyone have an answer for something like this? I almost kind of want you to mess this one up. Camille, do you have the answer? Yeah. And for some of us, you're probably like, whoa, 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 aren't we dividing? It's like, yes, we are dividing. But when we divide powers with the same base, we subtract the exponents. We're really doing 6 minus 3, not 6 divide 3, right? So if you would have told me x squared, I would have been like, oh, okay, we got to review this maybe just a little bit, but I think we can understand now we're just subtracting those exponents. That will become, the exponent laws here will become, I'd say a little important here, especially for common factoring. So maybe, especially this second exponent law, the division law, maybe star that one. That's a good one to refer back to. Okay, so essentially what we have here is a bunch of distributive property, and I know you love this stuff. The number out front multiplied by each term inside of the bracket. We're not going to show that middle step. Yeah, remember that? Remember even with FOIL? Maybe we show that middle step. I think I trust everyone here enough, especially in grade 10, to say, yeah, I think I know what's going on. 2 times 4x, we get 8x. 2 times 7, 14. So we get something like that. Okay? Now, this is where it can become a little bit tricky when you're dealing with negatives. So if you look, we have a negative 5 out front of the bracket, a positive 6x, and it says minus 9, but really that could be treated as negative 9. So negative 5 times positive 6x is negative 30x. And then negative 5 times negative 9 is positive 45. First two, so far so good? Give me a nod or give me a shake. Okay. Now, what happens here is that we kind of ramp this up a little bit by throwing an exponent out front of here, and maybe you're not even shocked at all by that. 3x times 2x, remember we multiply the numbers, so we get 6, and when we multiply the x times the x, we're going to add those exponents, right? 1 plus 1 will give us x to the exponent 2. And then we do 3x times 5, and that is 15x. Good? Okay? And lastly, this is where it can get a little bit messy. We got to be a little bit more cautious. 4x squared times 3x to the exponent 4. I take this, my brain works at one piece at a time. So I'm going 4 times 3 is 12, and then x squared times x to the exponent 4. We're going to add the exponents. And that's where you kind of got to have that internal battle in your brain where you know you're multiplying, so you multiply numbers, but then you have to, you know you're multiplying, you got to add the exponents. It's a weird battle, but I think we can see what's going on here. 4x squared plus 4x, times 4x squared will be 16x to the 4. Good? Any questions about the distributive property? Notice that the distributive property is all about multiplying, yeah? Whenever we expand, you even saw this on your test, expand and simplify, right? They're saying expand it, like multiply it, and then simplify, collect the like terms. Expand and simplify, that all has to do with multiplying, at least first. Now, factoring, on the other hand, factoring can be, well, quite literally, is the opposite of that. Now, there is an absolute ton of information here on this slide, and I feel like the reason why there's a ton of information is because you can always go back and read it if you wanted to, but it says here, to factor a natural number means to write it as a product. Write it as a product of other natural numbers, but not one, right? Because one would be a factor of everything. So for example, the integer 24 can be factored in different ways. So 24 can be a product of 6 times 4, right? It's great. 24 can also be written as factored, 2 and 12, 2 times 12. Also 3 times 4 times 2. Yeah? Remember that? And also 2 times 2 times 2 times 3. And I'm not sure if you might remember this. I know the grade 6s now are doing it. Do you remember that thing called prime factorization? Yeah? It's like that, you kind of start with a number, and in this case we're starting with 24, and they'll break it up into like, 2 and 12. Then you break up the 12 into 4 and 3. Then you break up the 4 into 2 and 2 until you're left with all those prime numbers. Remember that? Well, that's kind of what's going on. We're expressing a number like 24 as just a whole bunch of factors. Yeah, a product. Expressing it as a product of factors. So when we say that 24 is 2 times 2 times 2 times 3, we said 24 has been factored fully because none of these factors can be factored any further, right? We call that prime factorization. Are we okay with that? I'm going to draw a line right here because that's kind of a. Does that sound okay? You understand that? That feeling okay? So to factor a polynomial, right, like a polynomial, like a binomial, a trinomial, it means to express it as a product. That's all we're doing. It's kind of similar to this with the 24, but with polynomials. Now I'm pulling out the red highlighter because this is an important one. It says one way to factor an algebraic expression is to look for the greatest common factor. of the terms in the expression. The greatest common factor. Do you remember that? I mean, that's a blast from the past. I feel like it's almost like when you're, I don't know, maybe it was maybe it was, you're doing the lowest common factor, right? You're trying to get a common denominator or something like that. So the GCF, all right, I might call it that. Do you remember that? Oh yeah. GCF. Getting the GCF can be a little bit tough, and we did it different ways in elementary school, and I'll show you what I mean in these three examples down here. It says here, determine the GCF, the greatest common factor, for each of the following sets. Now, there are steps here. There's some wonderful steps that, if you don't know what's going on, maybe you can refer back to these steps. Maybe you can put a star beside them because they're great. It says determine the greatest common factor. Now, step one, determine the largest number, right? The largest number that goes evenly into each term. Remember when we were multiplying, we're doing the distributive property just over here? And I told you, once we got to C and D, I was like, okay, first the numbers, yes, then the variables, right? That strategy? Kind of the same idea when we're trying to obtain the greatest common factor. We're first going to look at the largest number that goes evenly into each term. So I think this is a great segue into this example one, yeah? Some of us might remember doing this. Oh, what's the greatest common factor? Okay, well, let's take 4, let's take 16, and let's take 32. Yeah? And it's like, well, we could basically just count by 4s, count by all these different things. But what is a number that divides evenly into all three of these terms? I know, yeah? 4, yes. Now, is 4 the greatest one? Yeah, absolutely. Now, understand that 1 is a common factor. You agree? 1 is a common factor. 2 is a common factor. 3 is not. But 4 has to be the largest common factor. So we could say the GCF here must be 4. Has to be. That's the largest number here. Now, I'm going to read step number 2, because step number 2 just has to deal with when we have variables. It says to determine the variable portion, which makes up the greatest common factor, you got to look at 2 things. The first one is that the variable or variables must be present in all terms to be a common factor. And the next thing to look at is the exponent. Well, the exponent on the variable in the greatest common factor is the lowest value exponent, which had been present on the variable in the original terms. I know it's kind of a mouthful. I think it's easier done than said. Yeah? So let's look at example B. If we're trying to obtain the greatest common factor here, just first, let's think about the number. What number will give us, what is the number part, I guess, of the greatest common factor? What number divides evenly into all 3 of these terms? Is it 3? 3. So far, we know 3 is a number that divides evenly into all these terms. And that's for the number part. That's great. Now, if you look at the variables, the variable x is present in each and every single term. That's great. We got that for step I suppose. But if you look, it says, well, the exponent on the variable in the greatest common factor is the lowest value exponent. Yeah? So if you look carefully, this first term, 3x, how many x's does it have? Just one? Just one. The 15x squared, it has 2 x's, and the 75x cubed has 3 x's. So really, they all have an x, that's great. Now they all have, I can suppose we could say, they all have at least one x in common, right? So, and if you look closely, the lowest value exponent here is 1. So our greatest common factor is actually 3x. Now, how about this last one? What we're talking about the GCF. What is a number that divides evenly into all, actually the biggest number, the largest number that divides evenly into all three of these? Anyone got it? Yeah. Yeah, it's 3. So, I'll write down 3. Now, when it comes to the variables, I'm going to do one variable at a time. I'm like, okay, I see x squared, I see x to the exponent 1, and I see x to the exponent 3. Essentially, what you can just go ahead and do is say, which one's the lowest exponent on the x's? And we can say, okay, well, that's x to the exponent 1 right there. So the greatest common factor will have an x to the exponent 1 in it. Now there's also a y. There's y to the exponent 1, y to the exponent 3, and y to the exponent 3 again. So out of all three of these, which one has the lowest value? The y to the 1. So the greatest common factor is 3xy. Yeah? Does that sit okay with you? Okay. Can I get some nods or maybe some shakes? Good? Okay. Great. Now, it says factoring is the opposite of expanding. You know, when we expand, we multiply like terms. When we factor, we actually divide. So we're going to bring together some of the exponent laws we reviewed and some of the greatest common factor things we reviewed. I'm going to show you how to factor. So if you look at this first example here, we have 4x multiplied by 2x minus 3. And what we can do flawlessly in here is we can take the 4x, multiply it by that, by the 2x to get 8x squared, and then multiply it by the minus 3 to get negative 12x. Yes? We're so good at that. And when we go that way, when we go this direction here, we are expanding. But what we're going to do today is we're going to start off here. And we're going to go the opposite direction. We're going to go the factoring way. We're going to go this way. Now, you could almost, maybe I want you to take 30 seconds. And I want you to look. And I want you to think, well, how does the greatest common factor fit into here? Think about it. Talk about it with someone near you. Maybe take a minute. Talk about the greatest common factor in there, and then look at the answer we're headed towards. So maybe take a minute, talk about it with someone around you, and I think you're going to see what happens here. What would be the greatest common factor? What happens if you have one x? And then what would be the number of x? Oh, not what's a great common factor? Or what? Correct on the answer somewhere? 2x minus 3 what's how can you yes. Where's the 2x minus 3? Yes. I think I know that you think. You think this. Oh, no, what's happening? How are we going? Yeah. Interesting. Okay, folks. A lot of people noted that this 4x here is the greatest common factor, right? It is. If you think about it, if we have 8x squared minus 12x, think about the greatest common factor for 8x squared minus 12x. The greatest common factor, well, the number part would be 4, because we have 8 and 12. And then the variable part would be x, because the lowest exponent on x is 1. Then my next question was, well, where did the 2x minus 3 come from? Now remember, factoring is the opposite of expanding. Instead of multiplying when we expand, when we factor, we're going to divide. So what we actually do is we divide out the greatest common factor, which sounds strange. I'm going to show you in this first example. We have 4n minus 10. Now, folks, between us, I'm going to write it over right here in red. What's our greatest common factor? What is it? Just 2. Our greatest common factor is just 2, and it's not 2n because the 10 doesn't have an n. So what we do with the greatest common factor is we're going to take a 2 out of this 4n minus 10 by dividing this by 2 and dividing this by 2. Now we got to make sure that we keep the 2 out front of our result, and we're going to write it as a product. Yeah? So what is 4n divided by 2? It's 2n. What's negative 10 divided by 2? It's 5. So what we can say is that the 4n minus 10 is equivalent to the 2 times 2n minus 5. And we're actually able to check this answer by using the distributive property. Like if we were to expand this, we would end up with the same answer as what we started with. And that's a lovely way to check your work if you needed to. Okay, let's try another one. Let's do this one in blue. We have negative 2y plus 4. Now, this one's a little bit tricky because whenever you have a negative in the first term, we usually want you to common factor out the negative, which sounds strange. You just got to take my word for it for right now. But I promise you it'll work out great in the long run. So our greatest common factor is going to be negative what? 2. Yeah. So we're going to divide the first term by negative 2, the other term by negative 2. And we got to make sure to keep the negative 2 out front here because we're dividing it out. So when we write this thing as a product, if it weren't there, then it's not equivalent. So we get positive 1y minus 2. Yeah? So this product down here is equivalent to the expression that we started with. It's almost like Spider-Man. Peter Parker and Spider-Man, right? This is Peter Parker. This is Spider-Man. It's the same thing in a different form. We call it, actually, what we're headed towards is factored form. Okay, next one. 3x minus 3. What's our greatest common factor here? What is it? 3. Genius. So we're going to divide this by 3, divide this by 3. We're going to keep the 3 out front, and we get, 1x minus 1. And if you don't believe me, we could just use the distributive property here, whoop, whoop, and we'll end up with 3x minus 3. Maybe we could even write that down. You can check by distributing. Because you can. Okay, the next 3 questions, they kind of ramp up a little bit here. I think I want to move this. Oh, just kidding. We have, I'm going to put in a 1 here, otherwise it messes me up. We got a 1x plus 3x squared. What's our greatest common factor here? Yeah, 1x, yes. So our GCF is 1x. So we're dividing this by 1x. We're dividing that by 1x. We keep the 1x out front of the brackets, and we're left with, now here's where exponent laws come into play, yeah? 1 divided by 1 is 1, and then x over x, x to the 0, right? So it's just kind of gone. The x's will cancel. So we're left with 1 plus 3 divided by 1 is 3. X to the exponent 2 divided by x to the exponent 1 is x to the exponent 1, because in that case we would subtract the exponents. Now, if you're not convinced, you can always distribute, and you'll end up with 1x plus 3x squared. Okay, how about this one? What's our greatest common factor? The first term is positive, so we're in good hands here. What's our greatest common factor? I think it's just 1y, or you could even just write y. So we're going to divide this by y, we're going to divide that by y. We keep the y out front, and we should get 4 minus y. Good? Okay, and the last one. Our greatest common factor here, because the first term is negative, I kind of want to common factor it out. So we'll say negative, well, 4 and 3, yikes. The only common factor, I guess, for numbers would be 1, but x to the 1 and x to the 2. So I suppose the greatest common factor is going to be negative 1x, or negative x. So we'll divide this by negative x, divide that by negative x, keep the negative x out front here, right, because we divided it out. So when we write this as a product, we'll get something like 4 minus 3x. Folks, any questions about that? The first 3, we common factored out a number. In the second 3, DEF, we common factored out a variable. Now, the last 3, this is where we're going to kind of do a combo of that. So, what's our greatest common factor for 3x squared plus 6x? Who's got that one? Yeah, Camille. Yes. 3x is our greatest common factor. We're going to divide this by 3x, divide this by 3x, keep the 3x out front of our bracket here, and we should end up with x plus 2. Yeah? Was that too fast, or is that like you're following along? You got that? Good, great. So 3 divided by 3 is just 1x, x2 minus x to the 1 is just that x, I suppose, to the 1, but we don't really need to write that. Okay, 24m squared minus 16. Greatest common factor? It's a tough one. Yeah? I thought, yeah, 4 is a common factor. I agree. 4 is, because 4, 8, 12, 16, 20, 24. And then also 4, 8, 12, 16. It totally is a common factor, but I'm not sure if it's the greatest. What do you think, Allie? 8, 16, 24, 8. 8 is the greatest common factor. So we'll say, okay, GCF is 8. Lovely. And we're going to divide this by 8, divide this by 8, and we get, keep that 8 out front. We'll get 3m squared minus 2. Sorry, the reason why there's no variable here is because there's m squared on the first term. There's no variable on the second term. So there's no way a variable could be a common factor here. Sorry, I kind of just got excited and blazed past that. Okay, now, the big one here. Whew. We have 12y to the exponent 4 minus 24y squared plus 48y cubed. Folks, it's our greatest common factor. Yeah, what do you think? The number part of the greatest common factor is going to be 12. I agree. Because it's divisible by 12, divisible by 24, divisible by 48, totally. Now, what about the variable part, Ryder? Y. Is it y squared? Squared is the lowest exponent. Absolutely. So what we're going to do is divide this by 12y squared, divide this by 12y squared, divide this by 12y squared. We keep the 12, let me rewrite that. We're going to keep the 12y squared out front of the bracket. And we're going to end up with, okay, one thing at a time. 12s are gone. We got 1 y to the exponent 2, because 4 minus 2 is 2, minus 24 divided by 12 is 2. Y squared divided by y squared, they cancel each other out. It's gone. There's no more variable. Lastly, 48 divided by 12, I think is 4. And then y to the 3 divided by y to the 2, we subtract those exponents. We get y to the 1. Any questions? Okay. Folks, you don't know this just yet, but I'm going to forecast it for you. Common factoring is the first step in factoring anything. Tomorrow we're going to learn how to factor some other cool things, but for today, nailing down this common factor is humongous. Now, there's 2 more examples that we kind of need to go over, because common factors are not just what we call monomials. Monomial, like a 3 or a negative 5x squared. Like that's a single term. A common factor can also be what I say a bracket, or maybe we could say a binomial. It can also be a trinomial too, but in this case they're both binomials. So notice that the 2 terms, right? We got this term here minus this term here. Notice what they have in common. They have exactly what's in the brackets common. The x plus 3 is a common factor of both of those terms. Do you agree? You see that? Okay, so what we're going to do is we're going to say to ourselves, yes, the GCF is x plus 3. And we're going to do exactly what we did before with the monomials. We're dividing this by x plus 3. And we're dividing this by x plus 3. So what we're going to do is we're going to keep the x plus 3 out front of the bracket. And what we're left with inside of the bracket is, well, x plus 3 divided by x plus 3 is kind of just 1. Like it cancels each other out. And then x plus 3 over x plus 3, again, it's 1. It kind of cancels each other out. So what we're left with is 5x minus 2. Questions about that? Yeah. Can I do it again slower? Yeah. How about, we'll do a second one? Okay. So, again, it looks a little funny, but it's quite literally the same steps as we took before. Folks, what's our greatest common factor for these two? Actually, Camille, can you help me with this one? What do you think that these 2 terms, we got the first term as this and the second term as that. Now remember, terms are separated by addition and subtraction. So this is for sure one term right here. This is another term. Now what do they each have in common? Do you see something similar about those 2 terms? Would you agree that they both have a 2x plus 1 and a 2x plus 1? You see that? So that is going to be their common factor. So our GCF is 2x plus 1. And as always, we are going to divide the first term by 2x plus 1. Divide the other term by 2x plus 1. And in our product statement down here, we're going to keep the 2x plus 1 out front. And what we're left with is the result of dividing by 2x plus 1, or maybe the result of dividing by the greatest common factor. So the 2x plus 1 will cancel with the other 2x plus 1, because anything divided by itself is 1. Yeah? So what we say is they cancel each other out. So what we're just left with over here is just a 3x. right? And for the second term, anything divided by itself is 1, so they just kind of cancel like that. And all we're left with is a positive 4. Now, that is a wonderful, wonderful move. It's beautiful. It's something we will continuously do throughout our factoring journey. That is like a monumental move in factoring. Does that help? Great. Okay. Now again, this is going to be something we refer back to, especially in the homework as well for tonight, and I think throughout, like I said, throughout the factoring journey, it's a great move. Now, in this last example, it says here when there are 4 terms, right? 1, 2, 3, 4. When there's 4 terms, they want you to find a common factor for the first 2 terms, and then one common factor for the next 2 terms. Now, these are kind of rigged up to work a specific way. They truly are. But the beautiful thing about factoring is that it's kind of the way factoring works. So don't think we're just playing house over here. Like this is real stuff that's happening, but I'm pulling pieces of the bigger picture so you can see what's happening before we get into that tougher stuff. So what we're going to do is first, like they say, we're going to group the first 2 terms together like that, and then the second 2 terms together like that. So when I look at this, I know color might do it for you, where it's like, okay, I almost got my blinders on like this, and I'm only looking at the first 2 terms. What is the greatest common factor between AX and AY? What do they both have in common? The A. So we're going to divide this by A and divide this by A. And we're going to keep the A out front of the bracket. And for the yellow pieces, we're left with, well, A divided by A, we're just left with X. And then A divided by A, we're left with minus Y. Good? Now, for the green, we have positive 5X plus 5Y. What do they have in common? What's the greatest common factor here? It's 5. So we're dividing the first term by 5, second term by 5. Now it was a positive 5, yes? So I'm going to write plus 5. And we're left with X plus Y. Now I almost wanted to, this almost looks like we could common factor out an X plus Y, but we actually can't here because the signs are different. Signs are, so that's as far as we can go. Okay. What we might call this is group factoring. Take the first 2 and then the last 2. Okay, and again, first 2 terms. Can someone tell us what the greatest common factor is of the first 2 terms? We got, I think it might be 2, yeah, 2 for sure, and then the lowest exponent on the x is 2, so it's going to be 2x squared. So we're going to say, okay, this is 2x squared, dividing that by 2x squared, and what we're left with is 2x squared, and now in the brackets we have 6x. I think I might need more room here. And then 2x squared divided by 2x squared is just 1 plus 1. Okay, now, second bracket. Sorry, the second color here, the greens. What's our greatest common factor here? First term's negative, so it's going to be negative what? 5. Yeah, negative 5, absolutely. So divide this by negative 5, divide that by -5. We keep the -5 out front of the brackets, and we're left with 6x and then plus 1. Oh, what do you notice? Can we factor it one more step? Yeah. What do they each have in common? What do the left side here? What does this term and this term have in common? Yeah. It's 6x plus 1. So what we're going to do is factor that out. We're dividing this by 6x plus 1. We're dividing that by 6x plus 1. And we're going to keep the 6x plus 1 out front. And our result after dividing is going to be 2x squared, yeah, minus 5. Okay. Folks, any questions? No? Okay. Now, I think what's imperative is this. This is super, super duper imperative. These last two examples, this is me planting a little seed for later. Now, there are questions like this in the homework, but they're not going to be the be-all, end-all, because this is great stuff, don't get me wrong, but it's stuff that we will certainly come across again. So if this time around it wasn't the most comprehensive, it will become comprehensive as time goes by, I promise. But anyone have any questions? No? Okay. So our homework here is on 203. I say 4 to 7, and we hit number 8, just factor it. It might ask you to do all these fun things, but just factor it. And then number 9, same thing, just factor. And then if you get a chance, try number 10 if you're interested.